So let's dive into the file. I already prepared the geometry, so I just can go through it quickly. So I got the car. I downloaded it from Render Crate. It's a pretty nice model, I think. But it's gotten too big, so I scaled it down a little bit. For the simulation, I used a simplified version of it. So I'm not going through node for node in this part, but what I did was I simplified the geometry. Then I picked it for the RBD simulation, and what I did is I made an animation, a short animation, and it's so you see the car is coming down, it slips, and then it stops. So what I did was I made a wrangle. And I deactivated the geometry of the car, and then at frame 8, the car will be active and then participate in the simulation. So it takes over the velocity and the rotation, and then and this I will. So with this animation you can control the how your car is moving, but still interact with the simulation. So I can show you here. So this is the import. So here I set up the DOP network, and if you can see how the car is going along now smoothly. So I won't go over the wall because we don't implement it. The gate we will need. So what did I do here? So I built the gate here. I built here the hinges. So the final geometry is this one. Is the left. Okay, from the other side. So the left and the right side. But I won't use this in the simulation. I will make a proxy geometry. So I just took the boundary box of this gate, and and I added the hinges, and so I made just a rough geometry. This I will use for the simulation. Also derived from the hinges here, I made the hinges fixed to the wall. So this is a separate object. I will use this the left and the right one. So this is what I will use. The chain I'm not going to implement now for now. So now I will set up the constraints. Make a new geometry. So I will call it sim RBD. So first I will get the hinges. They will not fix to the wall, but I will just fix them in the air. So object merge. So I have to get the gate. This one, and I will add the other one also. Fix right. So these are the hinges on the wall. So before I continue, I would just explain, probably, maybe you already know, of course, but the basic setup of the constraint. So I will show you a small drawing here. So basically, how the constraints are set up. It's actually, I will just draw it here. You got an object here, and you got an object here with points on it. So just really nice sketch. And what you want to do is link these two objects together. So by connecting the points like this. So this is the constraint primitive, and these are the objects. So important is that the points of the primitive have the same name as the name of the object. So in the sim it will be a backed object, so actually also a point. So this object will get a name, and for example, piece 0. This will get a name, piece 1. So all these points have also these names. The constraint will get a name, but this will be attribute constraint name. So now the simulation can see, okay, this point of the of this constraint primitive belongs to this object. This point belongs to this object, and this primitive contains also the not only the constraint name but also the properties of the constraint. So I hope it's a little bit clear, but anyway. So how to set this up then? So if we take a look at the attributes, these hinges don't have a name yet. So first we need to give it a name. So I will go through the objects as a complete with the connectivity node, and I want to go over the primitives to give it a name attribute. It's a string, and I call it, so it's a fixed hinge piece. So now if we go over the primitives, now it has a name, and it's piece 0, piece 1, piece 2, and piece 3. So this is, now I need to get the other side of the hinge, the gate actually, so I will import the gate. So I get the gate left proxy, and I get here the right. So now I need to get the hinges. I already equipped them. So I use a split here for the So what do I want to do now? For the hinge we need a straight line, and to get this we need some constraints in this line. So in my case, one hinge, I will create 5 point sets, and actually these are 2 points. So if I scale it up, so actually the next line is on top of this one. So what we will create is this is the hinge fix, and this is the hinge gate, and between that I will create the constraint. So this will be the hinge constraint. So this is for all of them. So this is one hinge, and I will make 4 of them. These points, these overlapping points, are on this surfaces. So first I want to isolate these surfaces. I already made some group for it. So use a blast, and it's the hinge rotation group. So I got these discs, and I also do it for the other side. So and I like to connect them now. So I will merge these together. Use a wrangle because I want to have points in the middle of these discs, because this will be my axis. So I go over the primitives, and I will create a new point. So add point 0 geometry. Okay, at point 0 geometry, and at the center position of the primitive. So if we take a look, see now, so here these points are created, but I like to add the attribute name of the 2 hinges on these points, so that it recognizes, so that will be the endpoints of the constraint primitive. So what I do now is set point attribute. So 0 geometry. I like to get the name of the primitive. It will be on the point. I will add the name attribute. What I do here is, so from the 0 geometry I get, I add a name attribute on the point and I get the name from the primitive, and I will set it on the point. So now these points should also have the same name. What I like to do now is so the rest of the geometry I don't need, so I will delete it, remove, move prim 0, at random with and the points. So what I need to do now is connect these points. I need only the points. So 1. So now I'll activate the rest link also. So these last points we don't need. There's no because we got probably about 20. Should have 20. 10 primitives. Of course, I also need the other other gate, of course. So now both are in, because I was expecting twice as many. So here, so now, so if we take a look now, 20. So and the unconnected points I don't need, so I clean it up. Delete unused groups out, so and remove degenerated primitives. I still want them, so now we got 20 primitives and 40 points. Now it's okay. So with this done, now we got I'll show them like this. We got the hinge points, and now we need to give them a name and some properties. So use a wrangle, go over the primitives as a string. Name is, we'll call it hinge constraint. I also need a constraint type. It's all for a hinge. For and I need the strength, so it's a float at strength. Yes, and I want to make it unbreakable, so we put in here -1. So constraint. So on this we can feed into the DOP network. So I'll call it RBD constraint Hinge. So for the others, for the geometry itself, I will pack them, assemble. I don't want to have the attribute names, but I want to have the packed objects. So, and I don't want to. This will be flying in the air and not participate in the simulation. So I will deactivate it with a wrangle. So integer at active is 0. This, and this will be the output. RBD geo Hinge. It's the fixed on the wall. So this is the hinge, and now we also need the doors. I will first make a simple door just to check if it's working. So merge the door. These are the simplified doors. Let's see, check, yeah. Let's check if they have a name, because otherwise, see, they don't have a name attribute. So if they don't have this the name of the object, constraint will not, the sim will not recognize it of the solver. So this will be cover the primitives, name, string, and this will be the left gate. Gate left piece, and this will be the right piece. Let's see, because now I've got this name attribute. The right and the left gate, yeah. So this is also actually use the doors here. So this will be one object in this, so I can use a symbol. Symbol don't want to rename. Create picked object, and it should be 2. Yeah. So this will be the geometry. So out RBD gates. So like this. So with this setup, now we can create the DOP network. So the DOP network I will create below this. DOP network. So I need rigid body solver. Need some gravity. Need a ground. And I need a packed object. To merge this in. So this will be the car, because the car already prepared. So the car proxy I need here. So let's see if it's there. Yeah. Let's check bullet data. Okay. Let's see if I can. Yeah, I use this. It's more precise. It's a little bit heavier, but it's fast anyway. So physical density I will set up later. So this is okay, and what I want is, because I have this animation controlled, I want to override it with the sub node and subs. So yeah. Let's see if this is working. Yeah, that's okay. Put out the points. Display geometry, and I will turn this off. So now I like to import the hinges. Also packed object. I will call this hinges. Because later I want to get these objects out, so I call this RBD car, RBD hinge fix. Gate hinge fix. Here out RBD geo hinge. Yeah. This one. Combine them. So now they're in. This I will leave how it is. Just okay, and then also I need to get the gate. So I will call RBD gates. So it is now the simplified version. Later I will make this that it deforms when the car crashes. But first check if the hinges are working. I of course need to make the constraint. And for this I will use a constraint to make a constraint network. No. Constraint network. I'll put it here. This will be the hinge. And I will use a cone twist constraint relationship. So I'll put it in. So here I need the primitives, the hinge primitives. And here I will have to change the constraint name. So it's looking at the constraint name. So was the hinge constraint. So it's appearing, so this is good. But now it's pointing the wrong direction. I want to have it in line with the hinge. So I have to set the direction. So this one. So now it's rotating here around this axis, and I can control it here. With the twist is in the up direction, so I want to have it only 60 degrees. So let's check if this is working. Let's leave this as default now. Let's play it. Oh, it's pretty quick. Okay. So seems to work. Okay, so here, this point it won't go in, so I will enlarge this position error that it tries to correct it. So I will set it to maximum, 0.8, and let's see. Oh, camera's in the way. So now it stays nicely in the hinge, because the problem is if it's snapping out, we have two hinges, it's not in line anymore, and then the door starts to wiggle. This is not what we want. But this seems to work. I don't know, maybe make this 90 degrees. Okay. So this looks fine. So now what I want to do is make this dents in the door. So what I want to do is fracture it and then make a glue constraint, and this glue constraint, when it breaks, will be a soft constraint, and at a certain threshold of distance, it will turn back into a glue constraint, an unbreakable glue constraint. So this is what we want to do. So I first want to create this fracture. So I use a Voronoi fracture for this geometry, and I need points. Scatter. Scatter some points, not too many. Now it's 3-dimensional, and I just want a 2-dimensional, just a simple fracture. So before this, I will use a transform, scale the Z value to 0. So now we have this plane. This will feed into the Voronoi fracture. So now I have a pretty, it's a simple fracture. So these pieces I want to give a name. So this is the gate, gate left piece. Yeah. So these pieces I will connect. Yeah, just leave it default, that's okay. I will do the same for the other side, so I just copy it. Of course I need this input and change the name. It's the right one. Right gate. And of course I also need this one. Now I have to give them the constraint properties. So just merge these together. Constraint properties like this. And I want to name this gate constraint, gate glue constraint, and I want to switch constraints when it's breaking. And then it will be a gate soft constraint. So the glue, oh no, 1000. This I will leave by default. Okay, I forgot something. I need also to connect the hinges, otherwise they fall off. So I will merge them. Now the problem is because with the simplified version I named it here, So this I don't want because I will I name them in the fracture, so I just delete this. I'll delete this for now. So now I have to create a name for the hinge on the gate. So it's also primitive name string. This will be the hinge piece, and this I will use for the don't have a merge here. Merge. Like this, and now it should be connected correctly. Also here, yeah. So now it's okay. These constraints I can use in the RBD. So this is the RBD constraints gates. And then of course I need also the geo. I need the actually I will use this. This fracture geo, and of course I need to assemble. Of course not connected. So now it's working. So let's check. So this I will put in the DOP network. So the gates we got. What we need to specify is the constraints of the gate. So I'll create a network again. A constraint network. No. So I want to have a glue constraint relationship. So first I will call this gate and I need to have the RBD constraint gate, yeah. And here I have to use a different name. There was the gate glue Constraint. Okay, yeah, it's popping up here. This is okay. And then we made another one. So for this I need a RBD soft. A soft body. A bullet soft constraint relationship. Sorry. Like this. Merge. And this will have the name gate soft constraint. So I will just check if this is working. Probably this is too much. I will go in here, I just make it 1. So I can control it in the DOP network. So let's check it. Press play. Okay, stop. So when it impacts, see the red constraints turn into these white ones, and these are the soft constraints. So these soft constraints have a distance attribute, and this I will use to control this distance and then turn it into a glue constraint. So we can do this by adding a subsolver. Sorry. Need to plug it into the constraint network. Like this. And I need the relationship geometry. So I make a wrangle. So what I want to do is get the constraint name. I want to get the distance attribute, and I want to get the strength attribute. So, and I want to compare it. Now I want to check if that distance is bigger than the make a threshold then okay, the name should change. Constraint name is, so it will turn into the gate glue constraint, and the strength of it will be unbreakable. So strength is -1. let's see. Okay, got some. I don't know. Okay, I forgot parentheses here. And of course I need to get a threshold. 0.02, just try it. 0 no, or even smaller. 0.05. Let's see if this is working. So now when I play the so I got it solved. The reason why it didn't worked was I forgot to put on the attribute the rest length. It needs it for the calculation, this distance. So this set on. Now we got this deformation of the gate. So of course it needs to be fine-tuned, but I will go over how to deform the gate and to get the car in. So go out, I save this. What I need is a DOP import. DOP. I put in a network, and this is why I need objects, the RBD objects. So I got them in here. So first I will replace the car. So I'll use a split here because these are packed objects and I need the packed object of the car. Car group. Import. Merge. Object merge. The car. Geometry. Use a transform. Transform pieces here. You put in the car and the other side. So now we got the car geometry in. So this car. On the other side I need to unpack. And I need the gate geometry. So I'll get the left side and the right side. So here and here. Also get the right and the left side. Of course I don't have a group created, so group, this is the gate left group. Here the gate right group. Of course. Group right here. Let's see now. So that's the left group. Now you will use this to deform the gate. So I use a point deform. So the mesh to deform is this one. Need the rest position of the deform geometry. So I'll put time shift 1. This goes in here, and then the deform geometry goes in here. So now it should, yeah, it follows. This is already good. The other side, do the same. I need this one, and this one. So let's check. Yeah, so see, it's deforming now. Merge this. We have the null. Gates. So this is this is then the results. Of course, could be optimized a little bit. Just put a drag node, top drag. Pop spin just to slow down the rotation and the flying around. Let's see if this is better. Yeah, it's a bit better, but okay. I think the point is clear. So with this I will end the tutorial. I hope you liked it and you learned something of it. I also here I put I've put other notes what I've used for this simulation. Maybe it's helpful. I always have to look them up. So yeah, then let me know what you think and see you next time. Bye.